So I can assume this side is x, this side is x, this side is the height, h. And the volume is 36 cubic inches. So you do length times width times height. X times x, x squared times height equal volume 36. And write h in terms of x divided by x squared both sides. So get h equals 36 over x squared. So that's the first step. Second one, if the material for the sides costs 15 cents per square inches, and the material for the base costs 40 cents per square inches, then ask you, what should the dimension of the cup to be to minimize the construction cost? So that means dimension. So figure out what is length, what is width, what is height. So figure out what is x and height. That's dimension. So minimize the construction cost. So you need the base and area, and you need to figure out the four sides area, add together. So cost in terms of the x is equals, and this side is the area, one side is x times h area, the other side also x times h, and the other side is also x times h, and then there's four sides, and each side is x times h area, and have four rectangle areas, four rectangles. So it's 4x times h is square inches is the area for the total four sides. Add together is 4xh. Question say the cost for the sides. If the material for the sides costs 15 cents per square inches. So this is the area for the sides, for four sides. Add together is 4xh. Times each square inches costs 15 cents. So times by 15. So that's total how many costs, how many cents to make up the sides. Add the bottom is area is x squared. The material for the base costs 40 cents per square inches. So it's x squared is the base times 40 cents. There's no top. The top is the open box. So that is the cost function. How many cents? Then simplify it. 4 times 15 is 60xh plus 40x squared. Then replace this h. H is 36 over x squared. Plug in. So 60x times h is 36 over x squared plus 40x squared. Cancel x. 60 times 36 is 2,160 over x plus 40x squared. And then I put them in order, in descending order. So put x squared first. 40x squared plus 21660. X go up by x to the power -1. And so this is the function for the cost, c of x. And one figure out what's x, make this cost minimum. So we take first derivative, c prime of x equal 40 times 2 is 80x minus 21, because negative times positive is negative, 2160 x to the power -1 minus 1 is -2. And make this first derivative equal 0, which is 80x minus 2160 x to the negative 2, bring down x to the power positive 2 equals 0. And solve this for the x. Since 80x over 1, so you times x squared both sides. Then you got 80x cubed minus 2160 over denominator is x squared equals 0. Then divided equals 0, so numerator should be 0. So 80x cubed minus 2160 equals 0. And move over, divided by 80, cancel, get 27. And x cubed equals 27, so x take cubic root, x is 3. Then you can check it. It is a relative minimum because the c prime take derivative again, c double prime take derivative, so get 80 and negative times negative become plus times 2 is 4320 x to the power negative 3 and bring down and x plug in 3 plug in is always positive. Add together is always positive. You don't need to figure out since 80 is positive, this part is positive, add together should be greater than 0. So x is at x equals 3 have a relative minimum. The cost is a relative minimum when x is 3. It's a relative minimum. Then the question asks you what's dimension. So first one, x is 3, you need to figure out the height. Height, plug into function equal 36 over x is 3 squared is 9. 36 over 9 got 4. So the dimension is 3 inches by 3 inches by 4 inches. X is 3, height is 4. 3 times 3 times 4 is 96. That's fit this. 36 cubic inches is the volume. Then next one, question 11. The altitude in feet of a rocket t seconds into flight is given by this function, the rocket. After t seconds, the rocket altitude, the height is so many feet. Degree is 3. Cubic polynomial function. Find the maximum altitude attained by the rocket. Maximum, so you can use second derivative test. First of all, you find the height is s. Height is distance s. So take first derivative. Get negative 2 times 3 is negative 6t. 3 minus 1 squared plus 3a4 times 2 is 768t. 2 minus 1 is t. And let this first derivative equal 0. Solve for t. So it's a negative 6t squared plus 768t equals 0. Factor out negative 6t. And here still have t. And here put the parentheses. Following this minus negative sign. Plus need to change to minus. You divide it. This divided by negative divide. Cancel negative 6. Cancel t. Get t. This 768t divided by negative 6t. Get negative 128. 768 divided by negative 6 is a negative 128. You times it become plus. Times it is a 768 equals 0. So then times together equals 0. So either t equals 0 or t equal 128. 128. T equals 0 is on the ground. Is 10 feet above the ground. So that is not the maximum height. So we figure out t equal 128. T equal 128 is a relative maximum. You check with second derivative. This first derivative, negative 6 times 2 is a negative 12t plus 768. Plug 128 in t. Figure out negative 12 times 128 plus 768 is a negative. If a negative is relative maximum. So then figure out maximum altitude. So 128 plug into original function s of 128 cube plus 384 times 128 squared plus 10. Figure out this is the maximum height. Maximum height 2,097,162 feet. Put down the units. It's in feet. Maximum height. This is use second derivative test and find out the maximum velocity attained by the rocket. So velocity is the height function s of t. Take derivative is the velocity. So velocity is s prime of t. S prime of t is we figure out is a negative 60 square here. Negative 60 square plus 768t. That's the first derivative. That is the velocity. This is a velocity function, v of t. Is this. And then how to figure out maximum velocity. You do velocity function, take first derivative. That equals 0. Solve for t. And velocity, take second derivative to check it is a relative maximum. And then you get the answer. So velocity function, take first derivative. Negative 6 times 2 is negative 12t. And add 768. That equals 0. Divided 768 divided by 12 get 64. And check this is relative maximum of v function. So this v takes second derivative. V takes second derivative is negative 12. Is this 768 take this 0. So it's negative 12. It's always negative. So when 64 plug in t will be equal negative 12 is less than 0. Second derivative is less than 0. At t equals 64, you got relative maximum. Relative maximum height of velocity. So what is the maximum velocity? You plug this t equals 64 into velocity function. T use 64 plug in. Negative 6 times 64 squared plus 768 times 64. And this use calculator you figure out is this. 24,576 feet per second is maximum velocity. Next question. A division of Chapman Corporation manufactures a pager. The weekly fixed cost for the division is $20,000. Fixed cost, for example, like a manufacturer, like a rental fee or utility fee as a fixed cost. The variable cost for producing X pages per week is this variable cost. X pages is depend on how many pages produced, and the get cost is this. The variable cost is dependent on how many pages X produced. So this variable cost add with this fixed cost is total cost. So total cost function is equal this variable cost with add with this, add together this variable cost with this fixed cost, add together is total cost function. And each pager can be sold at a price of $P, where P is related to X by the demand equation. This is demand equation. P is unit price equal X is how many demand equal negative 0.02 X plus 150. X is how many pages demanded. If all pages that are manufactured can be sold. So you manufacture, produce X pages, you sold out also X pages. Find the level of production that will yield Level of production means you produce how many pages. X, looking for X. How many pages? The number of pages. That will yield maximum profit. So you need to figure out profit function. Profit function is revenue minus cost is a profit function. Is profit. So first of all, you have to figure out what is the revenue. Revenue is how many units produced times the price per unit is revenue. You sell out P dollars, and then you total sell X units, X pages. Each page is P dollars. So revenue is the money you get income, your income. So X times P. So P is this one times by X. So get negative 0.02 X squared plus 150 times X. This P times X. P function times X. Get this. That's the revenue function. And the revenue minus cost is profit function because we are looking for the maximum profit. So we have to figure out profit function. Subtraction. Subtraction. Here, this minus this. Only this x cubed term because minus. So here get negative this x cubed term. This minus become plus. This become plus. Become negative 0.02 x squared plus 0.01 x squared combined is minus 0.01 x squared. 150x minus 50 is 100x. And this is 0. Constant term is 0. Minus 20,000 become minus 20,000. So subtraction. Subtraction and become this. Here plus change to minus. Here change to minus. So 150 minus 50 is 100. Here minus change to plus. Combine is a negative. And minus. So here change to minus. Change the sign. So get this. Take the first derivative. Solve for the x. So this 3 times net 0.00003 x 3 minus 1 is 2 and minus 0.01 times 2 is 0.02 x. Add 100 times 1 is 100 and let this equal 0. Let this equal 0, then those have decimals. You can change to whole number. So here has 1, 2, 3, 4, 5, 6. 6 decimal digits. So you move decimal point to the right 6 positions. Get 3. So this also move to the right 1, 2, 3, 4, 5, 6. So you need to fill in 1, 2, 3, 4, 4, 0. So and here change negative become positive. Change this negative become positive. You times negative 1 each term. And move decimal point to the right 6 positions and get 2 4 zeros. Times negative become positive become minus. And this 6 positions. So you will add 6 more zeros. Total 8 zeros. Here has 1, 2, 3, 4, 5, 6, 7, 8, 8 zeros. So become no decimal numbers. Then use quadratic formula. What is the quadratic formula? Quadratic formula is x equals 2a net b plus minus square root of b squared minus 4ac. Use this quadratic formula. Because if you don't know how to factor it, just use quadratic formula to do. 2 times a is 3, negative b is this 20,000 plus minus square root b squared, this 20,000 squared, minus 4 times a is 3, c is a negative, this. Then here negative become plus, negative become plus. So, and then this is a 12, add this 2, total is 16. And then here has 8 zeros. Here has 1, 2, 3, 4, 5, 6, 7, 8, 8 zeros. Take square root. 8 zeros take square root, become 4 zeros. And the 16 take square root is a 4. And then one positive, because x is in how many units? It's impossible negative, so we pick up, make positive. So here minus is a negative, then use plus. Negative 20,000 add 40,000, get 20,000 over 6. Reduce, cancel 2, and get 10,000 over 3. Divided is a 3. Remainder is a 1 over divisor, 1 over 3. So approximately 3,333 pages will maximize the profit. Maximize profit. And you can use double derivative on P to check, because if you take derivative on this to check, you do P double prime of x. P double prime of x, which is this one, negative 0.0000506x minus 0.02. And x is this one, you plug in, will be still negative, and this is negative, and always negative, less than 0, so it's a relative. This is a relative maximum. So it's make its maximum profit. You can check it by second derivative test. And the next one, it's you wish, question 13. Question 13. You wish to construct a closed rectangle box that has a volume of 4 cubic feet. The length of the base of the box will be twice as long as its width. So if I draw this box, the width is x, the length is twice of it, 2x, and this side is height. And when the total volume is 4, so you do length is 2x times width is x times height. 2x times x times height should be equal 4. And then you write h in terms of x, so it's 4 over 2x squared, that's h, and cancel 2, and get h equals 2 over x squared. That's the first step. The second one, the material for the top and the bottom, of the box, costs 30 cents per square feet. The material for the sides of the box costs 20 cents per square feet. And find the dimension of the least expensive box that can be constructed. So we need to figure out length, width, and height. That's dimension. So first of all, surface area. Surface is material. So first of all, figure out the cost in terms of x equals. Questions say 30 cents. 30 cents is the cost for the top and the bottom. Top is this length is 2x, this size is x, 2x times x. That's 2x squared. 2x times x is 2x squared is the bottom, and the top also 2x squared, so doubled, twice of it, twice of 2x squared. And each square feet costs 30 cents. So total is 4x square feet. And each square feet is 30 cents, so times 30 cents. Add the side. The side of the box costs 20 cents per square feet. So figure out the area of side. So this side is 2x times h. This side. Front. And the rear also 2x times h. So 2x times h is the front, and doubled times by 2. And the right side is x times h. Left side area is x times h. So double 2xh. and those 4 sides. Add together, each square feet is 20 cents, total times by 20 cents. And so this is the cost function. And figure out, simplify it. 2 times 2, 4. 4 times 30 is 120x squared plus 4xh add 2xh, total 6xh times 20. And multiply out 120x squared plus 6 times 20 is 120x times h. H, right, in terms of x is 2 over x squared. H replaced by 2 over x squared. Cancel x. 120 times 2 is 240 over x. Add 120x squared. And move this x to the power 1 up, become x to the power negative 1. And that's the cost function in terms of x. Take first derivative. C prime of x equals 120 times 2 is 240x. Negative 1 times 240 is minus 240x to the power negative 1 minus 1 is negative 2. And bring this x to the power negative 2 down, become 240 over x squared. And let this first derivative equal 0. So let this equal 0. 240x minus 240 over x squared equals 0. And since this is over 1, and you times denominator x squared, both sides, get same denominator x squared. Numerator 240 times x squared is 240x cubed minus 240 equal 1. And solve for the x. Because equals 0. Since equals 0, so numerator divided should be equal 0. So numerator equals 0. And move over, reduce, get x cubed equal 1. Take cubic root, x should be 1. You can check it. Check it, you use C function, double derivative, second derivative. 240x take derivative is 240. And here is negative 2 times negative 240 become positive 480 x to the power minus 1. Negative 2 minus 1 is negative 3. And bring down to the denominator, use 1 plug in. 240 add 480 is always positive. So positive, second derivative positive, so at x equal 1, the C function is a relative minimum. So get minimum cost when x equal 1 is the minimum cost. Then question asks you dimension, so you need to figure out the length. 2 times 1 is 2, and this size width is 1. Height is 2 over x squared. So 2 over 1 squared is 2. So put down the answer. The dimension is 2 feet. 2x, x is 1, so 2 feet by width is 1 feet. And by the height is 2 feet. Dimension is this. And you can check it. 2 times 1 times 2 is 4 cubic feet. And then the last question. Find the values of C such that the graph of f function. F function is x to the power 4 plus 2x cubed plus cx squared plus 2x plus 2. This one is concave upward everywhere. Concave upward everywhere. So it's going to be concave upward, which is the second derivative is a positive. So we find this function, first derivative, take derivative is 4 and 4 minus 1, so cube. And 2 times 3 is 6, 3 minus 1, so 6x squared. And 2 times cx, and 2 minus 1 is 2cx, and 2x take derivative is 2. Then take derivative again, double second derivative. So f double prime of x equal 4 times 3, 12. 3 minus 1 is 2, x squared. 6 times 2 is 12, x 2c. this one, this second derivative. And one concave upward, that's second derivative, need to be positive. So second derivative, the graph is concave upward. So you let second derivative greater than 0, which is 12x squared plus 12x plus 2c greater than 0. Greater than 0, then you can cancel 2 because the common factor 2. So divided by 2, 0 divided by 2 is still 0. So we got 6x squared plus 6x plus c greater than 0. So in this function, this one positive. This function is quadratic function, quadratic polynomial. One positive, that means y value is above x-axis. And leading coefficient is 6, is positive. So the graph is open upward. Open upward. And the graph, if have one solution, if this one have one solution, then will be touch with x, have one x-intercepts. If have two solution, then we'll have a touch with there's two solution. Then the function will be have 0. If this one equals 0, then either one touch or two touch that equals 0. And then those is a negative, those parts negative, those parts positive. And this one is those parts are positive and the only one is 0. If there's no touch with x-axis, then y is always above x-axis, above 0 is going to be greater than 0. So if greater than 0, this function, there's no x-intercept. No x-intercept. No x-intercept. No x-intercept. This kind of graph, no x-intercept. That means this one, you solve for the x. There's no real solution. This is one real solution. This is two real solution. This is no real solution. That means two complex solution. So if this function have two complex solution, the graph is above the x-axis. The function value, f double prime, y value is positive above x-axis, above this 0. Y is above 0. So that means this function solution get to be two complex solution, two imaginary solution. That means this function you take quadratic function discriminant. B squared minus 4ac need to be less than 0. Then this function has no x-intercepts. So you use discriminant. B squared minus f double prime x has no x-intercept. F double prime x is above x-axis. No x-intercept, above x-axis. That means this one, if you use this equals 0, then this one equals 0. Then this one equals 0. And if you solve it, solution for is two complex numbers. Then that discriminant b squared minus 4ac need to be less than 0. Then this solution is two complex numbers. Then the graph is no x-intercept. The graph is going to be above x-axis. So if you let this equal 0, if you make discriminant b squared minus 4ac, b is 6, minus 4a is 6, c is c, need to be less than 0. Then solve it is 36 minus 24c less than 0. Move over 36 less than 24c divided by 24. So get 36 over 24 less than c. Cancel 12, get 3 over 2. get C greater than 3 over 2. If the C greater than 3 over 2, then this one have a complex solutions. If the C greater than 3 over 2, this one has a complex solutions. That means the graph above the x-axis, the function value, this function value f of x is going to be positive. Function value is going to be positive, greater than 0. Greater than 0. So the answer is all the number greater than 3 over 2. They make this concave upward.